Hello, so today we're going to go over the AI part of our knowledge graph project. So basically what we are trying to do is we're trying to create a knowledge graph from a lot of personal documents, like which contains like the autobiography of a person. So it contains various types of data about them, about their work, about their childhood, about their current life, employment, vacations, so on. It can be anything. And then we need to accurately create a knowledge graph according to that data so that anyone who wants to learn anything about their life can just send a question and retrieve all of the accurate information from the knowledge graph. So the knowledge graph will have the documents, and with those documents will be attached the chunks. So let's say this is a small document which just has two chunks. Each chunk has the text which is stored in them. And yeah, so what our AI agent will do is that it will process these chunks and then it will create entities and relationships between them. For example, in this document where we have more chunks and this has already been processed, if we go over to the first chunk, we can see there are a lot of entities present in this chunk, like Salmon, Ryan, toy train, computer, Chinook, so on. So this is just all of the different people, items, food items that were mentioned in this chunk. And these are their entities created. And when we expand them, we will find all of the relationships that are created for them. So for Maisie, there's a relationship with John, Gallivan, Hilly for participating and likes. So for instance, John Gallivan Hilly loves to see Maisie. Maisie is a dog. So the relationship for John Gallivan Hilly to Maisie was created in the knowledge graph here. And then whenever in during retrieval, we will ask question like, what dogs did John Gallivan Hilly like? It will refer to Maisie as well, since we have this relationship created. And let's take a look at how this works. So basically, we give a advanced set of instructions to the LLM. We are using OpenAI's GPT-5 mini model for this. And we tell the agent to use the ontology that has been defined to process the documents. And the ontology is defined inside this ontology registry here. So it has like a list of entity types that are allowed and a list of relationship types that are allowed. And for now, the relationship types stay fixed, but whenever a new entity type is needed, since let's say we don't have an entity for food and we only have person, place, and organization, we will need a new entity for food type so that all of the food related items go into that entity. It will be automatically created by our database agent, and all of the logs for that are stored here in the ontology editions, where we can see in which document at which chunk was a new entity created. Like here we can see for symbol, for medication, for medical condition, a metric, a philosophical problem, and so on. So this is only created when necessary, and then we give it a lot of like different examples of how it should extract the entities and relationship types, and what are the rules for the entity types, some name normalization rules, how to propose the new entity types, and we tell it that the relationship types are fixed, and we cannot do that. Then we give it a strict output format that it needs to follow, and then it has certain tools to read the current ontology and to register the new types. And then it also has the database tools, which is connected to neo4j, this current database that we have. And based on whatever documents have been processed already, it will get the data about them. So let's say an entity about for John Hilly is already created. Then when we try to process another document which already has John Hilly's name there, it will use the same exact entity that was created before and not create a new one. So that prevents the duplication and that increases retrieval accuracy. And let's take a look at how this works. So let's run this file. So here we have defined the document that we will need to process and the number of chunks. So as we can see, it has retrieved 2 paragraphs from KGC. KGC is just like our actual paragraph, and it says 2 because we're processing this document and it has 2 chunks. So it gives us a glimpse of the source text, then starts extracting the entities. And when it does the entity extraction, it also retrieves if there are any relevant entities that already exist. And it found that one already exists that might be related to the text that is present in this chunk. And then it will try to use that entity if it's the exact one that has to be used. If not, it will create new ones. And this takes some time to complete. Let's just wait for chunk 0 to get processed, and then we can see the data in neo4j directly. So right now, since chunk 0 is being processed, so there's nothing here. While it is processing afterwards, what happens is the LLM does not directly get to write to neo4j. We have like a whole GraphOps architecture which uses a validator so that only the ontology that has been defined in our registry is used, nothing else. We have a models.py which defines this ontology and then checks against the validator. And then finally, we have an executor py, which is just a script. This is not LLM generated, so that we can like minimize hallucinations. And this is what is used to basically write to neo4j via GraphOps. So this is what's happening right now. It's going to run the executor.py file to write the entities and their relationships for this chunk. After this finishes, we can see the data directly in our graph database. Okay, now that it has finished, it built 28 nodes, 28 relationships, and bridge edges. Now we can go over and look at this data here. As we can see, there are a lot more entities now created here for photos and so on. Like, yeah. So that's how our AI agent works. Thank you for watching.